In today's video, I'm going to teach you an amazing trick on how to check if a given reaction is allowed or forbidden based on the conservation of baryon number. But before that, you have to know what is this baryon number or baryonic charge. This is the additive quantum number. And here we have three values of baryonic charge. B equal to +1 is assigned to nucleons and hyperons. Nucleons are proton and neutron. Hyperons are lambda 0, sigma plus minus, sigma 0, xi minus, psi 0 and omega minus. These are baryons. And B equal to -1 is assigned to anti-baryons, the antiparticles of baryons, okay? Antiproton, antineutron and so on and so forth. Now, B equal to 0 is assigned to non-baryons, those particles which are not baryons. They are photon, leptons and mesons, okay? Using this trick, let us see which of the following reactions is or are forbidden, okay? We are going to use the conservation of baryon number. If the baryon number is conserved, the reaction is allowed. If not, then it is if it is not conserved, then it is forbidden. Clear? Okay, look at the first one. Proton interact with neutron. So here we have proton, neutron and gamma particle, which is a photon, okay? So proton and neutron are baryons. So for baryons, what is the baryonic charge? +1, okay? For neutron also +1, here also +1. But this is not a baryon, so B equal to 0 for non-baryons, okay? So B, on the left, if we add, we have 2, right? On the right also, if we add, we have 2. Now here we have 2 on the left, 2 on the right. So baryon number is conserved, okay? So we cannot take this one. Okay, second one, proton plus neutron. We have an anti-electron and gamma. Both are baryons, so +1. This is an anti-electron or positron. And electron with its antiparticle are leptons. For leptons, B is equal to 0. Here also 0, non-baryons, okay? So on the left, here we have 2, on the right we have 0. Here baryon number is not conserved because on the right we have 0, on the left we have 2, okay? So this reaction is forbidden. And the third one, we have proton with neutron. We have a neutral charge baryon and then the antiparticle of a neutral charge baryon. Both are baryons. So B is equal to +1 for both. Neutral charge baryon and antiparticle of neutral charge baryon, these are mesons, okay? For mesons, B is equal to 0. So on the left we have +2, on the right we have 0. Now here baryon number is not conserved because on the left we have 2, on the right we have 0, okay? So this reaction is not allowed, that is, it is forbidden. So the reactions that are forbidden are B and C, whereas the first one, we see that the baryon number is conserved, that's why it is allowed. So in this way we check if a given reaction is allowed or forbidden using the conservation of baryon number. If the baryon number is conserved, then the reaction is allowed. If not, then it is forbidden, okay?